Hello YouTubers, followers, SSG followers and other followers. So once again some complication has arisen, but anyway, let me say following. This is a nighting charging procedure. I changed one part. I added to my system a lot of neon lamps like this, minus plus, and hopefully you can read my picture. If you not, just imagine 13 attached neon lamps at this connection, from the coil to the collector, and from the another connection from the emitter to another lamp connection, like this. So, and then I show you my measurement equipment. First of all, first device. This device should point. This device, laser pointer, I pointed with my laser pointer, showing the voltage of my battery which I charging. This device showing the milliamps which I getting from my system. So on this side, this is milliamps which I am getting when my primary battery running, and this is the voltage level of my primary battery. So, and this is a scope. To the scope I will go later. So once again, the system is set up on. This is why I getting here 12.37 volts, and this voltmeter connected to the lamps, yellow and white connection. You see this. So around my wheel like this, immediately something happens, so my battery getting charged. So you probably noticed this sign. This sign show me that my battery of my voltmeter is running low, but I'm pretty sure the values are almost accurate. So if you have a question, and in my next video I just change the battery of my voltmeter. But anyway, let's say following. The voltage of my battery was like, starting voltage of my battery was like 11.99, and yeah, this is a amount of milliamps which I am getting to charge my battery, but I am charging not by the current. I mean, I charge my battery by the volts, and this is actually how much I get. It's like 11.80 voltage through all these lamps. Then I have other side, primary voltage of my primary battery and the current which I get from my primary battery. So 12.34 voltage of my primary battery and 32 milliamps to run the system. Now I switch to my oscilloscope, and I should probably calculate how much impulses I have here. Let me just, okay, now let's start to calculate. 1, 2, 3, 4, 5, 6, 7, 8, 10, 8, 9, 10, sorry, 11, 12, and 13 and 14. So a lot, I'm getting a lot of impulses, more than 3 impulses, and the wheel is running like this. And let me show what happens when I disconnect one of the connections from my SSG circuit to the battery, like this. And immediately you see I have here a lot of lamps. Let me just switch off my primary light here. Okay, and this is just simple neon lamps. At first, when I today tested my system before I recorded the video, I found out that one lamp is not working, but other lamps, as you can see, working. So we can count how much lamp I have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 lamps, or even more. 3, 6, 7, no, 8, 6, other one side, 6, 13 lamps I have here on my. Oh, it's a little bit of the zoom. Let me zoom. So I'm getting so much lamps light on. This is like 230 amps each, but the voltage which is going through this lamp is like 11.18. This voltage I get between all of these lamps. So nothing special. My battery is not charging because I disconnected the system. Let me quick show the other part. The other part is my primary battery. Primary battery is showing me voltage 12.29 milliamps, 41, 42, 45 milliamps, which I am spending to run my system currently. And let's look at the voltages. So I did not change anything with the oscilloscope. I just disconnect my SSD circuit from my charging battery, and you see the value of the spike suddenly increased. So let me try some movement. So let's move my oscilloscope, and you see how high this impulse is. My oscilloscope cannot actually it's pretty amazing. So I'm measuring at voltage per division 0.5 or 5 volts. I would say 5 volts. 5 volts measuring here, and time value millisecond, 1 millisecond, time division, whatever here, level, time variation, position, and like this. But this picture actually very interesting. So let me bring some light. So, and yeah, and we'll work further with the oscilloscope. Okay, now it's better. So just I will try to do some stuff. Just switch on, switch off time division, so you probably will get better picture. So you see pretty high voltage spikes which I'm getting here. So even less. So what I'm just adjusting, 1 millisecond per division, 2 milliseconds, and this is probably even better picture. So let me just, so you see this is actually very high voltage impulses. So we can count the amount of impulses which I'm getting actually here with one transistor system. I'm getting here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 20, 19, 20, 21, 22, 23, 24, 25, 26. So like a lot, I'm getting a lot of impulses. And this is measuring at 2 milliseconds. Like now I will switch to the 5. Is even worse picture. Let me look at different type. Probably this will be okay. Now I have 1 millisecond. This is a 0.5 millisecond per division probably. Yeah, and I need to try, but you don't see my measurement equipment. If somebody have Tektronix in Germany, can give me for free, or I mean to rent for free, I would be very happy about this, but I do not have the Tektronix oscilloscope to measure this. Now I'm measuring 1 millisecond, and you see this impulse is pretty high. So positioning, let me do this. So you see a lot of impulses. I do not get I do not get free impulses like other people. I get a lot of impulses, and then what I do, I will show you voltage of the which I get. This voltage is actually voltage which is passing through all of these lamps. So one connection is here of my voltage meter, other connection is here. So I'm getting voltage. It's not 230 something, but anyway I'm getting lights here on. This is enough for me. So once again, 12.08 on the charging battery. I just need to reconnect the cable which is going from SSG circuit to the battery like this, and immediately battery is starting to charge. And this is what I get. This is milliamps. It's pretty low, 12.11, and this is running like this on 26 milliamps from my primary battery. I'm pretty happy about this. Yeah, like this. So what I supposed to say, at least to show you at the end, I will show you once again my oscilloscope. I just need to properly hold my camera. So amount of spikes you see here, I can probably do even better job to showing you. So let me do this right. So let's calculate the impulses. Just put my laser pointer. 1, 2, 3, 4, 5, 6, 7, 8, 9. But this is only on the value of time 0.5 per division. Let me do even less. Okay. Now I'm getting. I just changed it to 1 millisecond. So at 1 millisecond I'm getting here. Once again, calculate the impulses. And if you would like to know the leveling, you probably wrong, like this. Okay. So I just position at the middle of the oscilloscope like this, and you see amount of impulses: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 impulses on the 1 millisecond per division and 5 volts per division. So a lot. I'm getting a lot. And once again I just move the wheel, move the oscilloscope, and you see I'm getting a lot of impulses. So when we calculate from the end, from this side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And here we were here 12, 13, 14, 15, 16. So I'm getting a lot of impulses, and this is probably, I will say, from my system is the best results which I can currently get. And this is, I suppose, which you should get to when you're running the system in the best mode possible. So once again, what I will try to do right now, I will disconnect my oscilloscope from the system. Now you see nothing happening on the oscilloscope. Okay, nothing happening on the oscilloscope. Just disconnect oscilloscope, switch off my inverter, and what I'm really trying to show you, the way my battery is charging, and you see clearly it's charging. Sorry guys. And okay, you see, I should point out, this is showing me that my voltmeter going down. I need to change my battery, but I guarantee you the voltage measurement is accurate, pretty accurate. So it's very accurate voltage meter, and yeah, it's like this. What I should tell you about most things which I found very problem, it's lamps. And now what I actually try to do, I disconnect my voltmeter from this circuitry. Disconnected. Then I just move my additional voltage meter away, and now nothing changed. It's still charging the battery. And what I do next, I disconnect here the part. I disconnect my milliampere of my primary battery, and I need to do it like this. Okay. Okay, I disconnected my milliampere. Disconnected, and goes away. So I have the just connection voltmeter on this side, and so it does not change the amount of current and voltage. Voltage will you see it's trying to change, it will be changed. But anyway, I just need to disconnect additional ampere meter like this. So I disconnect it, and immediately you see this light bulbs, neon lamps just light on. And I need, okay, out of zoom. Sorry guys. What I do, I disconnect the milliampere from the charging battery. Once again, you see how it's changing. So now I have only two devices, measurement equipment, because you know measurement equipment can be pain in the ass with this type of technology. But you see for yourself, pretty amazing. And it's charging the battery as I expected. So next videos I will do my best, and I will even show you more. I will calculate the movement of the wheel with my RPM meter, RPM measurement device, and that's all. It's charging the battery as expected, and you should do the experiment like I show you, and yeah, you should see a lot of spikes when you're running this type of system. So thank you all, and bye bye.